What are the statistical methods used to analyze events? Some essential notions are discussed in this presentation. Let's take the fictitious example of an observational study in real-world settings where we want to compare the proportion of patients without adverse events, bleeding, stroke, etc., during surgery between two groups of patients benefiting from two different surgical techniques, one standard and one innovative. The appropriate statistical method for making this comparison is called logistic regression. The association between the exposure and the outcome is quantified by the odds ratio. In our example, the estimated odds ratio is 0.4. What is the interpretation of this result? Assume that there is no difference in the odds of adverse events between the two groups. The estimated odds ratio is close to 1. These values are plotted for ease of interpretation. If the estimated odds ratio is greater than 1, it can be concluded that the probability of adverse events is higher in patients exposed to the innovative strategy than in patients receiving the standard strategy. This would be a risk factor for adverse events. If the estimated odds ratio is less than 1, the probability of adverse events is lower in patients receiving the innovative technique than in patients receiving the standard technique. This will be a protective factor against adverse events. This is the case in our fictitious example. Let's go on with another example. Let's imagine an event that can happen at any time in time, tomorrow or in 3 years, and that the patients are not all followed over the same period of time. This is the case in oncology where we want to compare the time to death between a group receiving a new treatment versus a group receiving the reference treatment. The definition of the endpoint considers the temporal dimension. If there is no death observed during the follow-up, the event is said to be censored, and the time between the beginning of the study and the date of the last news is calculated. In order to assess whether the risk of dying are different between the two groups of patients, the statistical method is called a survival analysis, which is performed using a Cox model in most cases. The Cox model estimates the strength of the association between exposure and the instantaneous risk of an event by the hazard ratio, sometimes called relative risk in French, taking into account the fact that not all patients are followed for the same time. In our example, the estimated hazard ratio is 1.2. Whether it's an hazard ratio or an odds ratio, the interpretation is the same. We see that the hazard ratio is greater than 1. The new treatment will be a risk factor for death. Its interpretation is as follows. The instantaneous risk of dying is about 1.2 times higher in treated subjects with a new treatment than in subjects treated with a reference treatment. For information, survival data are classically represented by survival curves calculated according to the Kaplan-Meier method, but we will not go into more detail here. On the other hand, in other situations, it may be relevant to choose as endpoints events that may occur several times in the same subject. In cardiology, we will be interested in whole hospitalizations for heart failure. For this patient, we will thus take these 4 hospitalizations. One of the models that allow us to integrate the prediction of the studied event is the Anderson and Gill model, which is an extension of the Cox model. The measure of association and its interpretation remain similar to the previous hazard ratio. Thank you for your attention.